Hello and welcome to this PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. If you're joining us live, please remember that you can ask questions anytime throughout the webinar. You don't need to wait for the Q&A section at the end. We'll queue your questions up and ask them when it's time. When you do ask us questions, please be sure to include some information about where the question is coming from. That could be a city, a school name, a teacher's name, or maybe even a student's first name if it was one particular student's question. And we'll be sure to give you a shout out when we ask that question on your behalf. So let's get to it. We have our guest today coming from Laurentian University. His name is Dr. Aaron Langille. He is a master lecturer in computer science and video game design, and he's from the Department of Mathematics and Computer Science there at Laurentian University. Thank you so much for joining us, Aaron. I will let you take it away.
Thank you, Stacey. Good morning, everybody. I'm going to take a moment here to share my screen and to get my presentation up and running. It is right here. All right, so hopefully that is visible for everybody. Now, what we're going to talk about today is video game design. And since we have a very limited amount of time, I've sort of titled it just a primer on video game design. Video games and computer science are tied so closely. I mean, without computer science, we don't really have video games. And you know what? Video games actually help us with some computer science problems as well. So what we're going to take a look at today are some of the essential video game items that are closely tied to computing, and some of the first things I think you would need to know if you're going to get started even writing video games on your own or as a class, or maybe you want to consider this as a career. So I guess the first thing that's worth mentioning is that video games are extremely interdisciplinary, which is, you know, just a fancy way of saying that people from all sorts of disciplines get involved. They're quite amazing for this fact, as it turns out. I mean, you can have story writers and artists, musicians for good music, and level designers. But I suppose if you're here during Computer Science Education Week and interested in Hour of Code, I guess the important part, and maybe I'm a little bit biased for this, but I think it's the coders that kind of tie everybody together. So it's the coder that's going to take all of these pieces, you know, whether it's the pixel art or the music or the level or the text, the dialogue, and is going to tie all of these things together and then do some other things as well. So while I don't want to diminish those other roles, I think we're here today to talk about the coders in particular. So let's start with probably the first and one of the most simple things that video games need to be able to handle, and that's animations. If you think about maybe the last video game that you played, I'm sure that there was something moving on the screen pretty much constantly. A lot of those types of movements, you know, even when your character isn't moving left or right or jumping, a lot of those sort of smaller movements are done with animations. And what happens is an artist, or you know, maybe the coder has some art skills, or maybe you go and get some art from a website that offers free assets. But what ends up happening is you have this series of images, kind of like the one on the screen. So this is actually from a freely available set of assets that you can get if you want to practice video game design. And all of these particular images, if you look at them from left to right, sort of form a walking sequence. And what video games do is they play these images over and over again, so that when your character is walking or jumping or running or doing any action, the same images sort of repeat over and over. Now, if the action changes, we can change the images, but what you basically have is something similar to an animated GIF or GIF, if you prefer. And I want to talk just really briefly about the computer science that would happen behind something like this. So if we were to break this down and talk about an algorithm, a very simple algorithm, which is just a computer science recipe, it might look something like this. So if we start at the very first image in the sequence, and as long as our character is walking left or right, we're going to show the first image. If there's more images in the sequence, then we're going to advance to the next image. if we reach the end of our image sequence, then what we're going to do is we're going to loop back. So what this is it's a very fundamental computer science structure called a loop. And I would imagine that some of you out there have some experience with loops. Some of you might not. Either way, this is one of the most fundamental things both in computing and in games, since it's loops that keep the game moving. So here's what it might look like closer to actual code. This is sort of Java or C++ like. So again, if you're familiar with this kind of structure, maybe you recognize some of the pieces in there. And if you're not, this is one of the first things that you would probably learn in a computer science class once you're through some of the even simpler things. This would be the next step to move on to. So this is how a lot of the things end up looking animated in our video games. Luckily, a lot of the game engines take care of this work for us, but if you were to try to write something from scratch, this would be the kind of code that you would be looking at. Probably the next most common thing that our video games have to worry about is something called collisions. And collisions happen all the time, and things are bumping into each other, and this is how hit points are lost, and this is how enemies are defeated. So aside from animations, collisions is probably the next most common thing that you're going to see. And again, a lot of video game programming languages like Unity and GameMaker will take care of a lot of this work for you, but it's worth knowing what happens underneath the hood in case you ever had to refine something that they're doing. So what happens in a nutshell is our two characters here, so our hero on the left and say our small enemy on the right, would be surrounded by something called a hitbox or a bounding box. And we calculate several times a second whether or not those boxes overlap. So we'll take the center point of our hero to the boundary of its bounding box, and we'll take the center point of our enemy to the extent of its bounding circle in this case, and we'll constantly test whether or not they're overlapping. Now, the only reason there's a plus and a minus here is because our hero is moving in the right direction and our enemy's moving in the left. But what we're constantly doing, and it tends to be at the rate of either 60 or 30 times per second, is we're checking to see if those two bounding areas, the box or the circle, have overlapped. So below I've put another little piece of code that kind of shows, if the hero position plus the size of their bounding box is greater than the enemy position minus the size of their circle diameter, then we have a collision. So maybe both of their health gets reduced or something like that. Most of the time, nothing happens at all because our two characters are not going to be constantly colliding with each other. So most of the 60 times per second, we're really checking for nothing. But this is something that video games do all the time. They're constantly checking for collisions. If they get close enough, we're going to end up with a scenario that looks something like this. And this is when the game engine or your program is going to register a collision, and that's when we're going to take care of either the damage or whatever we decide we're going to do with a particular collision. So that's kind of how those work. And again, if you think about the most recent game you've played, maybe you're playing one on your phone right now, this is happening constantly between all the objects. It happens between your characters and platforms. It happens with the things that they pick up. This is one of the most frequent things that's happening in video games. And the logic to test whether or not things are colliding is actually fairly straightforward. If we take a look at sort of a classic example, I mean, there are so many collisions happening in this one little animation. So we have what's effectively a collision with the slingshot before our red bird gets shot out. We have collision with the original board, and then we've got all of the subsequent collisions, and all of this is happening roughly the same way that was described in the previous slide. We're constantly checking to see if the red bird is in contact with any of those things, and then as the boards start to fall, we're checking to see if they're in contact with the green pig and whether or not they're in contact with each other. So all of this follows that sort of simple logic that was happening in the previous slide. This is what a collision might look like if you were writing a game of your own. So this is in a program called GameMaker. This is looks a little bit more complex than what I showed previously, but the core logic is actually the same. What's happening in the screen furthest to the right, so that big window, is we're deciding what to do in the case of a collision. So this is actually a game that we've been prototyping where galaxies run around and shoot stars at each other, and stars can be gobbled up by other galaxies. It's kind of cute. We're still working on it, but all of that logic that's in that big window is just there to decide what to do with each particular star. So while it looks complicated, it's just the result of going through and just making decisions one after another about what to do. And this didn't all get written at once. This was written between play testing sessions. We would go in and decide that we wanted to do something else. We'd go in and we'd edit it. So don't expect, if you do start to do this, to be able to write that much code all at once. Just take it a little bit at a time, and you'll see that over time you'll develop something that you think is pretty cool. So the next thing that's kind of interesting and gives us something to look at from a code and a programming sort of perspective is something called parallax scrolling. Now, you might notice that all of my examples today are 2D, but everything that we're talking about is actually applicable in 3D. It's just that 2 dimensions tends to be a little bit easier for us to grasp when we're first learning things like this. So there are 2 different images here, and what I want to draw your attention to is the fact that in each one of them, the foreground is moving faster than the midground and the background. And this is actually a trick that we use to make 2D games look 3D. And you'll find that this goes way back. And when I say way back, I mean when I was probably your age, even games were doing this to simulate that 3-dimensional effect. So this is a very common thing to do. Now, a lot of people, when they start game design, they look at this and they think, wow, that must be kind of tough. When in fact, if we break it down into its individual pieces, it's actually a simplish thing to do. Now, I want you to picture that scene that's all the way to the right as kind of an endless runner type game, which I'm sure a lot of people are familiar with. If you're not, it basically means that the game keeps moving whether you're ready or not. And what we see is that we can actually simulate this by moving each one of the components at a different speed. So it's actually not that difficult of a problem to do at this level. So the clouds, for example, are moving at speed -1. The cactuses or hills or plants are moving at speed -5, and that shrub in the front is moving at speed -12. Now, again, like I had a couple of slides ago, the only reason that there are negatives there is because they're actually moving to the left. And when we look at the pixels on our screen, 0, 0 is to the left, so that's why it's negative. Not something you usually need to worry about right away, but just wanted to make sure that if anybody's curious, that's why. So parallax scrolling, which gives a beautiful effect to most games, can actually be done fairly easily. Now, we don't have anybody moving in the foreground in this case, so I'll move there. And in this case, it's the same sort of idea, but we need to make it slightly more complicated because our character isn't always moving in the same direction, and they're not always moving at the same speed. You know, if I'm coming up to a river of lava that I have to cross, I might want my character to slow down. So what we tend to do more often is we make our speeds relative to how fast our player is going and the direction that our player is going. So in all of these numbers that you see at the bottom, we assume that our player speed is X. So, you know, they could be not moving, and that would be 0. They could be moving to the right at +5. They could be moving to the left at -5. And then what we do is we adjust each one of our layers accordingly. So again, it's not an overly complex trick, but something that you need to think about. And we can move our background and we can move our foreground relative to how our player is moving, as long as we do it by thinking through the problem and using things like simple multiplication. And again, a game engine will take care of a lot of the background work, and we can make sure that we have sort of a neat parallax effect to our game. So this is just a little example. This is kind of a mashup between a couple of Mario games. It moves pretty fast. but you can see that as the character slows down, all of the other corresponding movement does as well. It's kind of jarring to a player when the character stops and the background still moves, and it's kind of jarring in vice versa as well. So one of the nicest things you can do for your players is give them a little bit of fairly straightforward parallax scrolling, which is a fancy term for a fairly easy technique. I don't know that we really have time to talk about physics. I would love to talk about physics. I think it would be a presentation onto itself, maybe even a series of presentations. So much is done in video games now that mirrors real world physics. And the reason for that is because we know quite a bit about real world physics, and we are able to simulate the equations for things like gravity and thrust and velocity, all sorts of things that we can do because we know the math to them and that computers can calculate them fast enough. So I have Sackboy there from the Little Big Planet series because I feel like he's a very good example of what we would call ragdoll physics, where all of his limbs sort of move independently and he sort of flops around depending on what he happens to be doing. If you haven't seen it, you can definitely look up some videos on Sackboy and Little Big Planet and see sort of how he functions, and all of that is done through math that the computer is able to calculate. I've got the Angry Birds image showing again, just to remind you of all the physics that are going on there, and actually the equations that are above it are related to Angry Birds. So those are part of what's determining, how fast the red bird is when it hits, what trajectory it's following. And so these are things that we can do. And again, I'm going to say thank you to the people that write the engines that make these games, because a lot of this stuff is built in. So if you're going to use GameMaker or Unity or Stencil, which I'll mention briefly at the end, you'll get access to a lot of these gravity and velocity-based physics, and you won't have to worry about the math so much. Again, here's a little example from a game I was working on in the past. Sometimes you want to take control of the physics yourself. So those little rings that come bouncing out of that chest are actually being done with the math that's in that code window on the bottom left. So basically what you're seeing is us handing some of the physics over to the game engine, which again in this case is GameMaker, but we are controlling the variables to make sure that we get the effect that we want out of those bouncing rings. So just kind of a demo from something that we've worked on in the past. Level design is a really interesting topic that doesn't have a lot to do with coding at first, because it's a very artistic process and doesn't require a lot of algorithms when you're doing sort of a straight platform type level design. Now, there is a coding aspect to it, and I'll get to that in a moment. And I just want to make sure that I'm not selling the artist short. There's certainly a lot of work. There is absolutely a reason to have a good level designer on your development team, whether or not that's you or somebody else. Level design can truly make or break a game. If you're doing static level design, and static's just kind of a fancy word to mean it doesn't change. So the level's always the same. And we play games that are static all the time. If you're doing static level design, it's more about placement. So you can see the grid. Hopefully you can see some of the grid lines that show up on this image. And it's about placing the images and setting up the background layers. Those yellow lines indicate places where we didn't want our character to be able to go through the walls. So those are collision walls. So there's a lot of work to be done with level design. Now, sometimes we want to give our players a slightly different experience. And what we do is we generate fresh levels using random number generation or using all sorts of techniques so that every time they play, the level is slightly different. So what we can do is we can start out with something that is that doesn't look like a level at all, and through various processes, and this is where the coding gets a little bit more complicated, we can generate levels that are unique and interesting every time a player plays. And again, I would imagine that most people out there have played games that have different maps, different layouts every time they go in. And these are just some of the, these are just examples of some of the techniques. The coding is somewhat more complicated for something like this, so I don't have an example of it right now. But one of the things that you have to make sure if you're doing something like this is that players can actually get out of the level. So it's actually something that requires a little bit of thought and a little bit of testing, but it's definitely one of the more code intense places that game design tends to go when you get to this sort of experience that you want to give to your players. So that's pretty much what I have to talk about for video games and coding. I don't want to sell the coding short, but in our limited time, I just wanted to give you kind of a sample of what I would see from my students and what I've been involved with in the past and what you can do to start. I have some suggestions here for anybody that wants to start programming. Python is a great language to start with. Google, Go, and Java for people that might be more intermediate to advanced. If you want to get involved in starting with video games, I highly recommend Scratch. If you're really brand new, Stencil, which is also based on Scratch, is also for beginners. GameMaker and Unity are going to push your coding a little bit harder. So make sure that before you start with those, you have sort of the background in loops and variables and if statements and stuff like that. So you want to make sure that you do a little bit of practice beforehand. My Twitter username is up there for anybody that's interested in contacting me, and a couple of hashtags that I use all the time are there as well. So I think that's my part.
Well, thank you so much. I think it was really easy to follow with all of those animations, the things that we often take for granted as I'm being transported back to my my early Nintendo childhood at this moment. A lot of visions of Mario coming through my head right now. But I wanted to ask the very first question being to touch on those if statements or what a loop is, those sorts of things that you mentioned briefly, or we saw examples of if and else. How does that work?
So we can write code that is linear, and that just means that it runs line 1 and then line 2 and then line 3 and then line 4 all the way to the end of the program. The problem is that sometimes we need to make decisions. Sometimes we need to say, you know, if I'm colliding with an arrow, I need to take a hit point. So that an if statement is basically a decision structure that allows us to say, if something has happened, you know, if a number has gone to 10, if some event has occurred, then we're going to respond to it. Else, we might respond to it differently. So it's basically a fork in the road for our code, and we get to decide whether or not we're going to go left or right. And the way I describe loops to my first year university students that are, you know, some of them are just starting coding for the first time as well. Loops are things that simply run over and over again. So there are times that we may want to repeat an action, and we'll put that in a loop. So for example, when we talked about animations, that particular animation had 11 frames to it. We don't want to play the 11 frames and then stop. We want to play the 11 frames and then run them again. So that looping structure allows us to repeat actions. And that's what if statements are. They're branches, and that's what loops are. They allow us to repeat things.
Wonderful. We have our next question now coming from Ms. Rubini Laforest's class. Wondering if students are interested in video game design, what are some post-secondary programs they could consider?
So if you look around, for people that are in Ontario, I highly recommend going to the Ontario University Fair and talking to universities that may have video game programs. I recommend talking to guidance counselors, and I recommend looking on the websites of institutions that, universities and colleges that are in the area that you'd like to go to. There are a number of colleges that offer video game design as a program. I'll give you the example of Laurentian, since that's where I'm sitting right now. We offer a Bachelor of Computer Science, which has a specialization, so that's kind of like a minor in video game design. And what we do is we spend more time than other programs might on coding and doing sort of core computer science, and then we give students what I suppose would be the equivalent of a minor. So we give them a little bit of extra push in video games so that if they decide to go on and be a game designer as a career, they've got that extra bit of education. So there are a number of places in Ontario. I'm sure there are places in every province that offer video game design, either at the college or at the university level. And I believe in a lot of cases, the guidance counselors will be aware of that at the high schools. And if not, again, my contact information is there. Feel free to reach out to me and I will help track some down.
Thank you so much. And just as a follow-up question to that, is there any main difference for students whether they chose a university program in computer science or a college program?
I'm not familiar with a lot of the college programs to that level. Laurentian was involved in a sort of a web-based project to get all of the video game programs into a database. And I guess the easy answer is that every program is somewhat different. The colleges, to the best of my knowledge, are going to focus a little bit more on the tools and tend to focus a little bit more on techniques like animation and maybe even how to integrate the music in. And a lot of the universities will focus more on the coding. So how to integrate those pieces as opposed to how to create those pieces. When my students do their projects, I recommend that they get together with students from other areas within the university, and I don't expect them to be an artist and to be a musician and to do all of those things themselves, but rather to focus on the coding since they're computer scientists. I believe at the college level, they'll do a lot more sampling of the various things that go into game design, but there may be some university programs that do that as well. I know that there are some university programs that focus more on the social aspects of games, like what can we say with games, how do games affect people, than they do on the programming of games as well. So that's a question that you have to ask a few institutions and sort of get a feel for what the variety of programs that are offered is.
Right. Thank you so much. And I think at this point, I'd like to ask you to stop sharing the slide. I think our audience has had time to copy that down. If not, you can certainly refer to it in the recording or give us a shout if you need any of that information. Our next question is coming from London, Ontario, and they're wondering what is the difference between GameMaker and Unity from a high school student's perspective?
GameMaker will only do two-dimensional games. So let's get that right out of the way. If you're looking at playing with 3 dimensions, you'll need to hop into Unity right away. There are ways to simulate 3 dimensions in GameMaker. So there are games that are called isometric, where you look sort of from an angle top down. That can be done in GameMaker, and things like the simulated Parallax can be done in GameMaker. But if you want to do actual 3 dimensions, you are looking at moving to Unity. The coding in GameMaker is a little bit simpler. The scripting is a little bit more forgiving than it would be in Unity. Unity has a little bit stricter and more standard programming syntax. Whereas GameMaker is a little bit more forgiving. GameMaker also has a visual programming mode, which is good for people that are just starting. So if you go back and look at some of the screenshots, you might see some of those visual aspects where a collision can be handled by dragging a button into place instead of writing code. For people that are just starting with A, programming, and B, game design, I recommend GameMaker. I recommend people move to Unity once GameMaker no longer does what they need it to do. So, and there are also price differences. Unity, unfortunately, the pricing is kind of backwards for what I just said, because Unity is available for free, and GameMaker you can only get for a 30-day trial, and then I think it's a few bucks after that.
Right. So maybe not terribly expensive, but also not free after that 30 days. So you got to learn quickly,
Yeah.
I suppose.
Yeah.
Okay, well, we have now a question coming from, excuse me, Mr. Hosman's class at RMSS in Timmins, Ontario. They're wondering if you could talk a little bit more about the fundamentals of game design, like how to make games more fun.
Well, again, that's a series of talks. How to make games more fun. There are two approaches to making fun games. One is to follow your heart, and one is to follow the research. And what I recommend to my students is they do a combination of both. So video games, from a technical perspective, handling collisions and handling animations and handling parallax scrolling, those are the kinds of skills that we can teach in high school, even in lower grades, or in high school, or in university, or in college. We can teach those kinds of skills, but what we can't necessarily teach is fun. And what makes a game fun is very, very subjective. So some of the things that you can do are to design games that are similar to games that are already out there, and simply have some changes to them. So, there are lots of clones of Angry Birds, or even Mario style clones, that you can download all of the art and some of the basics for the game, and then you can start playing around with some of the properties, and you can find out whether or not making your character jump twice as high is fun or not fun. You can find out whether or not having spikes everywhere and things that perish your character all the time are fun or not fun. It really is something. The fun aspect is more the artistry of game design, and you can tap into psychology, and you can say people like games that do this, or you can ask people to play your games and ask them if it's fun. I think one of the things that is very, very important to do if you're going to even attempt game design is to be thick-skinned, because people are going to say, I don't like this. And sometimes they won't give you a good reason, and sometimes they will give you perfectly good constructive criticism. But a lot of my students, even in their late teens and early 20s, find it very difficult to accept that criticism. But it's very important, if you're going to have a fun game, to listen to your audience. So they will tell you, this jump is too high. It makes the game too easy. It's not fun. These spikes are too plentiful. I keep dying. The game is not fun. And you have to choose to either respond to them or to keep following your intuition that the game is fun. So again, there are technical tricks to it, but there's also an artistry to it. And most people do not write a first game that is fun. It usually takes a handful. And it's like any sort of art, whether or not you're learning to draw or to paint, you need to build up a portfolio. And the process of doing that, you will learn what things are fun and which ones are not. But it's definitely a process.
There we go. I can imagine that it would be quite difficult when you put all of that work into the background. You showed us how complicated that code can be for a simple jump within a game, and to have someone come back and possibly be quite blunt about constructive criticism or just criticism. I can imagine that would be difficult. But if you're going to build a game for the masses, it might not be exactly the way that the designer would think it would be most fun. So let's move on to another couple questions before we go. First, we have a question from Sacred Heart High School in Stittsville, wondering if there are any online courses or resources that they can point students to if they want to learn a bit more about game development independently.
Absolutely. Both Unity and GameMaker have an absolute ocean of tutorials online. What happens with my third year game design students is I teach them to code in first and second year, and then in third year we leave them on their own to learn either GameMaker or Unity or whatever it is that they're going to use. And they do that through tutorials on their own time, because we focus on aspects like integrating art and story and the game design scene. We don't have time to teach them the game design mechanics. So I let them loose on the internet. And a lot of those resources are definitely high school appropriate, or even, grades 6, 7, and 8. A lot of them will walk you through step by step, so you don't even need to know how to code anything at all. They will walk you from start to finish. One thing to look for are Code Academy type tutorials. So I don't want to isolate any one vendor in particular, but if you start looking, if you Google GameMaker tutorial or GameMaker platformer tutorial, depending on what kind of game you want to make, you will find a ton of resources out there. Sometimes the more structured ones that'll have a part 1 and a part 2 and a part 3, so that people can take their game to a more advanced level. Sometimes they go on sale. I remember picking up a couple of courses that I gave to he was probably 13-year-old at the time, for about $6. So they can be quite cheap when they go on sale. And again, some of them require absolutely no coding, whether or not it's GameMaker or Unity, and students can go on their own pace. But there's just an absolute mountain of them online, because they want people making games. And the more people that are making games, the more good games we will get.
Right. So I think we need to wrap up, but before we do, I wanted to ask you a question that came in from Assumption College in Brantford, wondering what first sparked your interest in gaming and coding, and to follow that up with what advice or direction you would give to any students who might wish to pursue this from here. So how did you first get started, and what would you suggest that the students do if they are sparking an interest?
So without giving away my age, I was also a Nintendo kid. I played on VIC-20s. I played on Commodore 64s. I'm sure there are a couple of teachers that are nodding their head right now. Commodore 64s, VIC-20s. I was the kid that would try to avoid going out for recess so that I could play video games. I don't recommend that. Kids, if you're listening, don't do that. Go out for recess, play video games later. Video games were not as accessible as they are now. So when they were available to me, I tried to play them all the time. So I got into video games as a player as a kid, which followed me all through my primary grades, all through high school, and somewhat through university. I would play games. And I went into computer science as a program for my university, and we did no game development at all, which was mildly crushing at the time. But I sort of bounced back when I came back to university, to work at a university later on, and we decided to put the video game design program in place. So my experience with video games was based on being a player, and sort of came back, it inspired me to go into computer science. And then when I came back to be a professor, I wanted to bring video games back into our department and give students the experience that I wasn't able to have because it just wasn't offered. So we started the game design program based on some experiences that we had, and then I wrote my first video game, which was released a couple of years ago. And I have half a dozen more that I'd like to work on when I get the time. What I recommend for anybody that wants to start is to pick the right tools to begin with, because getting frustrated is not a good way to learn. If you are brand new to coding, consider starting with something like Stencil or like Scratch, just to get a feel for what a loop looks like, to get a feel for what a branching if statement looks like, to get a feel for what collisions actually do, and focus on the game, not on the code. When you find that those tools are no longer adequate for the game vision in your head, branch out into things like GameMaker, where you're going to have to do a little bit more coding. than you would have in those other platforms. When you're too big for that platform, move on to Unity. But take it one step at a time. Try not to get frustrated when people say, you know, that doesn't seem very fun. Use your first few games as a stepping stool to making better games later on. Your first few games are not going to come out like you envision them in your head, but after a few, that'll start to happen. So take it slowly, pick the right tools, and move to other tools when you're ready.
And we had a webinar yesterday where our other computer science expert had mentioned how when she puts together anything new, so she wasn't doing gaming, she was doing some prototyping of different things and programming them to do whatever it is she wanted them to do. And she said she still has almost an aha, exhilarating moment whenever it works. There's lots of frustration along the way and fixing bugs and that sort of thing. And then when it finally, you set it in motion and see if it works the way you intended and it gets even close, she said she still has that feeling of pride and excitement that you've worked so hard in the background and then you finally see it come through. Do you still have that feeling as well?
Oh, absolutely. I mean, having been a computer scientist for a very long time, and writing the first game was an aha moment. There were aha moments while writing the game, you know, when we made those rings drop out of the box. Like, that's every time you do something that does kind of match that picture in your head, it feels really good. And the trick is to keep going. And you know, there are also tricks about if the project isn't working the way you want it to, maybe consider starting another project, because you don't want to let something that really isn't working for you bog you down. So there's lots of ways to keep progressing, and the trick is to just keep at it, and practice makes perfect. It's just like learning a musical instrument. Game design, computer science, all of it, programming is just like playing a musical instrument. The more you do, the better you get.
Well, that is all the time we have. Thank you so much for joining us, Aaron, and showing us all those different animations and different challenges in game design, how to get around them, and the advice for students who may want to pursue this so they know where to start.
My pleasure.
Next week on PIR Live Event, we're doing a follow-up for the teachers out there. If you want to take your computer science education from sort of 1 week of the year, if you're not teaching a designated course, and spread it out over the year and do some more, then we have a PD webinar next week. We also have a webinar next week on autonomous vehicles for students in class as well, just like this one. So please feel free to find more information at our website at pirweb.org about these webinars and the other educational programs that we offer. Enjoy the rest of your computer science education week, everyone, and we'll see you again. Bye-bye.